String theory is a theoretical framework in physics that attempts to describe the fundamental nature of particles and the fundamental forces of nature. It is a theoretical framework that combines quantum mechanics and general relativity, and it proposes that the fundamental building blocks of the universe are not point-like particles but tiny, vibrating strings. Point particles versus strings. In classical physics, particles are considered to be point-like objects with no size or internal structure. However, in string theory, particles are replaced by tiny, one-dimensional objects called strings. These strings are assumed to be the fundamental building blocks of the universe. Vibrating strings. In string theory, strings can vibrate in different modes, similar to the different modes of vibration of a guitar string. In string theory, strings can vibrate in different modes, similar to the different modes of vibration of a guitar string. The different vibrational modes of a string correspond to different particles with distinct properties, such as mass and charge. For example, the electron is associated with a specific vibrational mode of the string. Extra dimensions. String theory also introduces the concept of extra dimensions beyond the three spatial dimensions, length, width, and height, that we experience in everyday life. These extra dimensions are compactified, meaning they are curled up and not directly observable at macroscopic scales. String theory requires the existence of 6 additional spatial dimensions, for a total of 10 dimensions, to be consistent mathematically. Quantum mechanics and gravity. One of the major motivations for string theory is to unify quantum mechanics, which describes the behavior of particles on very small scales, with general relativity, which explains gravity and the curvature of spacetime on cosmological scales. String theory naturally incorporates both quantum mechanics and gravity, providing a potential framework for a theory of everything. They embodied both wave and particle nature, defying conventional understanding and embracing uncertainty. String interactions. In string theory, interactions between particles arise from the way strings can split, merge, or interact with each other. The properties and behavior of particles are determined by the interaction of their corresponding vibrating string modes. The mathematical description of string interactions is more complex than that of point particles, but it provides a way to describe the fundamental forces of nature, including gravity, electromagnetism, and the strong and weak nuclear forces. Multiverse and string landscape. String theory suggests the possibility of a multiverse, a vast ensemble of universes with different physical properties. The idea is that the laws of physics and the values of fundamental constants can vary in different regions of the multiverse, resulting in different universes with different physical properties. This concept arises from the many possible ways in which the extra dimensions of string theory can be compactified. It's important to note that while string theory shows promise as a potential theory of everything, it is still a subject of ongoing research, and many aspects of the theory are yet to be fully understood and tested experimentally. Nevertheless, it has provided valuable insights into the nature of particles, gravity, and the fundamental structure of the universe. Thanks for watching.